PSC1-5 is actually going to be a bit of a shortcut for some of the problems you've been doing. So the idea on PSC1-5 is that parallel lines within triangles are going to split the sides proportionally. So in other words, I can say A over B has to equal C over D. And notice A and C are on the same side, B and D are on the same side. I don't want to say A over B equals D over C. I could say A over C equals B over D. All right, the opposite also works. So if two sides are split proportionally, so if A over B equals C over D, then the lines are parallel. So sometimes you'll be asked to tell me whether two lines are parallel, and you want to just set up a ratio and see, are those two ratios equal? All right, it works multiple times as well. So I can say A over C equals B over D. When I get to something like this, I can do the exact same thing. A over D equals B over E equals C over F. And when I'm working with this, I would only pick two at a time. Right, so maybe I'm working with these two, solve for a variable there, and then if I had another variable, I would pick either that first one and the last one and rewrite it as A over D equals C over F, or I would just look at the last two. Okay, sometimes kids see three in a row and they kind of freak out. They don't know how to solve it. Just work with two at a time. All right, we're going to set up an example. So EO is parallel to LN. 48 is across from 60. Just like 36 is across from Y. To solve for Y, I just need to cross multiply and divide. So 36 times 60 is 2,160. Divide by 48, and you get Y equals exactly 45. Same idea here. These lines are splitting the sides proportionally because they're parallel. So 8 over 9 has to equal 10 over x. 9 times 10 is 90. Divided by 8, you get 11 and a quarter. This time we're asked, are they parallel? So I'm going to check, is 12 over 15 the same as 16 over 25? Okay. 12 over 15 is going to simplify to 4/5. 16 25ths does not simplify at all. Okay? And sometimes kids are like, oh, but if I took the square root, I would get 4/5. You can't just go around taking the square root of whatever you want. Okay? So we have to say that no, these two are not equal. So no, the lines are not parallel. On my last example, I'm asked to solve for x, y, and z. We're going to start with x and y, and then talk about why our shortcut doesn't work for z. So 4 over 5 has to equal x over 4. Now I'm just cross multiply and divide 16. So 4 times 4 divided by 5 is going to equal 3.2. Do the same thing for y. 4/5 equals y over 6. 6 times 4 is 24. When I divide by 5, I get 4.8. Now when I look at z and 6, I can't say that 4 to 5 is the same as 6 to z, because 5 is just in one triangle, and 6 and z aren't being split. This shortcut only works on the sides that are being split by those parallel lines. It doesn't work for the parallel lines themselves. So instead, I need to pick sides that actually correspond. So if I pick 5 and then that whole side, and 6 and this whole side. Now I'm using sides that are proportional. So I'm going to say 5 to 6 equals 6 plus 4 plus 5, so 15 to z. 15 times 6 divided by 5 will be 18.